bit is the protecting diodes and uses of diodes. Okay, so protecting a diode. Diodes will allow large current to flow through. So effectively, all you do, if you're asked how do you protect a diode, you protect a diode by putting a resistor in series. That's it. Now I want you to add this to the bottom of the page or to the side page of where semiconductors are in your notes. Okay, that's protecting a diode. Okay, use of diode. Allows current to flow in one direction, but it has one major use. It's used as a rectifier. Okay, now a rectifier changes AC to DC. Okay, so watch what happens. Okay, and we have what's called a half wave rectifier. Okay, a half wave rectifier. So what you have is you have AC coming in, goes through the diode. Okay, you have what's called a load resistor. This is where the output is going to come across. Okay, so the output is here. Right, the input, the output. So the input is AC, so it'll look like this. Okay. Could be a current time, or it could also be a voltage time. Okay. Now the output, okay, and I'll actually draw it underneath, it'd be better underneath. So okay, so think about it. When this part is plus and this part is minus, current will flow and you'll have an output. So in this part here, current flows. Okay, when it changes to minus plus, which is this bit, the diode will not allow current to flow. There'll be no current, so you basically get this, nothing, and then you get a current again, and no current again, and a current again. Now that's called half wave rectification. Now it's not great, because remember, for DC you expect, this is what you want for DC. Okay, you just want a constant current or constant voltage. Here what you're actually doing is you're removing the negative part, and that's it. Okay, we can improve it. So the first improvement we can make is by adding capacitor, and it's called a smoothing capacitor. So watch what it does. So just draw the circuit again. So we have the same circuit, and this is a use of a capacitor, so it's useful to know. You have your diode, and you also put a capacitor here in parallel to your resistor. So your diode, your resistor, in parallel to your resistor. You can have the other side, it doesn't matter, and you have your output here. Now what happens then, okay, I shouldn't have drawn it underneath, but I'll just put our new one here. Okay, is what happens is, it goes up like this, but the capacitor, as it's coming down here, the capacitor stores the energy and releases it slowly. So instead of going down and across, okay, I'm going to just start each of the three of these. What happens is, it just kind of fades away like that, and fades away like that, and fades away like that. So it's been smoothed. Okay, and if you look now at what we're getting, this color, okay, this is your output. That shouldn't be there. That shouldn't be there. This is your output. And you can see it's coming closer to that. There's also a thing called a full wave rectifier. Okay, now a full wave rectifier is not in the full wave rectifier is not in the second level course, in the physics course, except in the option, the applied electricity option. Regarding applied electricity, we will come back to that. Remember, we've done the particle option, but those of you especially doing engineering might find the applied electricity option very useful. So we're going to do that as well separately as an option for you. You can decide to do it or not to do it, but we'll come back to that later. Okay, so there are the uses. Okay, so that's protecting the diode and the half-wave rectifier. And the half-wave rectifier, that's the diagram. You can add in the capacitor, so it's effectively the same type of capacitor, and I want three diagrams to show. The input and the output for the half-wave rectifier without the capacitor and with the capacitor. Okay, now I want you to put all of that into your notes. So on the blank page opposite to the left of your page on semiconductors, put that in as well. Okay, done.